In this series of videos, we're going to be looking at index laws in algebraic contexts. Before we continue with this, you need to make sure you are comfortable with the following ideas from topic N7a. The big idea is that, in general, a to the power of negative n is equivalent to 1 over a to the power of n. This is always true no matter what value a takes, as long as it's not 0. Let's have a look at a quick example. 2 to the negative 5 will be 1 over 2 to the power of 5. Now 2 to the power of 5 is 32, so 1 over 2 to the power of 5 equals 1 over 32. Right, let's have a look at the activity. We need to match the equivalent pairs of expressions. Let's note down the key fact that we need to know for this. A to the power of negative n is always equivalent to 1 over a to the power of n, except when a is 0. Let's start with this first one. We've got 3x all to the power of negative 1. Let's stick with what we know. We've got a quantity to the power of negative 1. So that is simply going to be equal to 1 over that quantity. So that means here is our matching expression. Let's look at this next one. We've got, again, a quantity to the power of negative 2. So that means this is simply 1 over that quantity squared. Notice how important these brackets are. So we have 1 over 3x all squared. Unfortunately, this is not one of the options we've got available down here. But what we can do is notice what this actually means. 3x all squared is just 3x multiplied by 3x. We're squaring 3x, so multiplying it by itself. And 3x multiplied by 3x is 9x squared. We've got 3 multiplied by x multiplied by 3 multiplied by x. Don't forget the invisible multiplication signs in here. So our denominator here is really 9x squared. And we've now got a matching expression down here. It's this one. Let's have a look at the next expression. That's this one here. This looks similar to the first one, but there's one key difference. In the first one, we've got these brackets, whereas in this one, we don't. What this means is that this is actually 3 multiplied by x to the power of negative 1, whereas the first one was 3 multiplied by x all to the power of negative 1. Now, if you remember your order of operations, you will recall that indices take priority over multiplication. So we're going to do x to the negative 1 first before multiplying it by this 3. Remember, there's an invisible multiplication sign right here. 3 multiplied by x to the negative 1. So writing that down, I get 3 multiplied by x to the negative 1, which is simply 1 over x. Now we can multiply these together. If you prefer, we can think of 3 as 3 over 1. And multiplying fractions is easy, remember. We just multiply the numerators, and that gives us 3. Multiply the denominators, that gives us 1x, which is just x. So we have 3 over x, which is this one right here. Now I'm going to skip the next couple for now and go straight to this last one, which looks very similar to the one we've just done. The only difference is that we've got an index of negative 2 here instead of negative 1. Pause the video and see if you can identify which one of the expressions down here is the one that matches this. Here's what you should have found. What we have here is 3, or 3 over 1, multiplied by x to the negative 2, which is simply 1 over x squared. And multiplying those, we get 3 over 1x squared, or just x squared. So this matches this expression down here. Let's move back to this one. X to the negative 3 using this index law just gives us 1 over x cubed, which means it matches this expression down here. That just leaves one pair left. We've got x cubed and 1 over x to the negative 3. So they must match. But let's see what's going on. We know that x to the negative n equals 1 over x to the n. Now, if we choose n to be negative 3, what we end up having here is x to the negative 3. X to the negative 3 is just x to the positive 3, which is what we've got there. And that means because we said n was negative 3, I can replace this n here with negative 3. So I have x cubed being equivalent to 1 over x to the negative 3, which is that one there.